Yesterday we did an activity where we matched exponential equations to see relationships between them. We kind of solved them by comparing them. Today we're actually going to use a graphing calculator to solve them. So we're going to write down the steps to do that right here. Always make sure before you start these that you reset your calculator, and that's second plus 712. But today, to solve these, there's actually more than one way. We could look at a table, or we could trace and actually get the image. So we're first going to press y equals. That's the first step. And then we're going to type in the function. And for this example in the function, this part is going to be y1, and this part y2. Okay. Once we type in the function, we're going to press second, and then we're going to press trace. And then we're going to press the number 5, which is intersect. We'll wait for it to load after we do that. And then we'll press enter 3 times. So we're going to do that with the first one. You're going to take some time to do those with the next one. So we go to y equals. So see, I've cleared my calculator because it says RAM is cleared. Okay. We'll press y equals, top left button, 5 raised to the x power. Make sure you put x, not some number. That's y1. Go down to y2 and type in 625. After you've typed it in, you're going to press second, which is the blue button, trace, which is one of these top gray buttons, and number 5. We want number 5 because we're looking for where these intersect. You must wait for it to graph and this to come up at the bottom, or you are not going to be able to press enter. You will freeze. The calculator will freeze. So once I've got this, I'm going to press enter 1, 2, 3 times, and I have my intersection. It intersects when x equals 4 and y equals 625. Notice these numbers match. They're always going to match that 625. I say always. They will not always match. It depends on how complicated your equation is. They match right now. For all of them that are just equals a number, they should match. Okay. So x equals 4 is my solution to x. We're going to go down. We're going to do these out of order. We're going to do number 4 and then number 7. These are just plugging them in the calculator, which means you need to stop this video and practice plugging them in the calculator. You really don't need me to continue to plug them in the calculator over and over again. I'm going to show you another example, but you need to be able to do this on your own. Number 4. I'm going to go back to y equals. I'm going to clear it out. Alpha y equals, enter, 1 over 12. Type it in just like you see it. Sometimes the calculator will take away the parentheses because it knows it doesn't have to be there. If it takes them away, fine. Otherwise, you need to put them in all the time. Second, trace, 5. Wait for it to come up. And enter 1, 2, 3 times. See, the y's match, like I said, depends on how complicated it is. This one is also x equals 4. That's just a coincidence. It's not that they're all going to be x equals 4. Okay, keep going. Pause the video. Try number 7. Alpha y equals, enter, 2 fifths, parentheses, 10 to the x power, over, and then I've got 40. Second, trace, 5. Wait. One, 2, 3 times. X equals 2. To check them, you can plug into right here and make sure you get 40. You can also look at them and see what number you think you're going to need. It's easier to determine what number you think you're going to need by moving this over. Let's look at the next side. Same process. Four parentheses 2 to the x power. 128. Second trace. 5. Wait. 1, 2, 3. X equals 5. Y equals, clear them out. Four fifths to the x. See, I told you sometimes it will take out the parentheses because it doesn't need it. Don't worry, the calculator knows what it's doing. Second trace, 5. Wait. This one looks very low. 1, 2, 3. X equals 3. Okay. I'm going to zoom out and let you see all of these. You need to go back and do every single one of them. I'm not going to continue to plug them in the calculator. Make sure when you plug this one in, it's 6 to the x over 16. The exponent goes with the 6. You've got a second to be looking over these. So look over them, compute them, figure them out. I'm going to tell you the answers in a moment. Alright, now that you've had time to work them out, or should have, if you don't have, you're not done, pause the video, keep trying them. Number 8 is x equals 5. Number 3, x equals 4. Number 6, x equals 2. Number 9, x equals 3. Make sure you got those right. If you did not, make sure you typed them back in correctly. If not, ask me a question. The next day of this, we would talk about word problems. This video is actually a 2-day lesson. This will be the first day. Secondly, we're going to talk about word problems with exponential functions. We will then solve them. In the back of your notebook, in your answer document, your reference sheet for the test at the end of the year, you have two formulas. You have an exponential growth formula. That exponential growth formula is y equals a times 1 plus r to the t power. You also have an exponential decay formula. And that formula is almost the same, except it's y equals a times 1 minus r to the t, as it is decay. Let's talk about what each of these mean. Y will stay in the problem. A is the beginning, whether that's time or population or whatever, it is the beginning. R is the rate, normally in a percentage, but you have to convert it to a decimal. T is time, often in years, but it depends on what the problem actually states. In today's problem, we are going to highlight our beginning value in all of these in green. I'm going to highlight the beginning value in green. We are going to highlight the rate in orange. Time normally stays as a variable. But we can highlight it in pink in case we have it anywhere in the problem. But normally it remains as the variable. Okay? So let's look at number 1. We're going to talk about how we can find whether it's first exponential growth or decay, and then how to create one of these equations. So number 1 says create an exponential function and then solve by graphing. So we're going to do both. Number 1, a town with a population is expected to grow. Key word there, I'm going to highlight that in blue. It's going to grow at an annual rate of 5%, annual meaning year. Write an equation and find the number of years it is expected to take the town to reach a population of 900. So first of all, a town has a population of 600. That is the beginning. That's its starting value. It's expected to grow, growth, at an annual rate, our rate, of 5%. Here's what I know. I know I'm going to use this formula. So I'm going to write it down. Y equals A, parentheses, 1 plus R to the T power. A, 600, that's the beginning. Plus R. R is the rate. Our rate is 5%. However, I need that in a decimal. 5%, you move the decimal place 2 places to the left, is the same as 0.05. So 0.05. I need to add those together. 600 times 1.05 to the T. That is the first step. Create an exponential function. It says then solve by graphing. To solve, I'm going to use this. This is the question. We have written an equation, but now we need to find out how long it takes to reach 900 years. That's the final population, Y. So I need to determine what 900, or when the population will be 900, if it starts at 600, grows at 5%, what year, time will that be? This is what I'm going to plug in the calculator. It is no different than what we did yesterday. I need to reset my calculator so that I get the right answer. Go to Y equals, make sure it's cleared out, 900, and then 600 times 1.05. Raise it to, I don't have a T, I need to put X. Then second trace 5. Wait till it comes up, it'll take a minute. See, it did not show anything because it's way above, but I do know it's here. 1, 2, 3. 8.3. So T, it's approximately 8.3, and it says years. Both of these are my answers. I need to erase that a little bit so it actually boxes it in all the way. Number 2. A wolf population is 400. Okay? Beginning, 400. The population is growing. So we're going to have growth at an annual rate of 8%. 8%. From that sentence, I can write my equation. y equals a parentheses 1 plus r to the t. Y equals, the beginning population is 400. 1 plus 8% is the same as 0.08 to the t. After a while, you can quit writing the rate down if you just realize it's 8%. So 400, 1.08 to the t. That is the first part. I'm finished with the first part. The rest of this question says, first of all, write an equation, but we're done. And find the number of years it is expected to take the wolf population to reach 700. That means, when will this, what year will this reach 700? Again, I'm going to type it in my calculator like I did. Y equals, clear this out from the last one, 700, 400 times 1.08 to the x power. Second trace, 5, wait, the glare is bad. Let me move this up so you can actually see it. These take longer. It takes longer for your calculator to actually figure that out. Okay, 1, 2, 3. 7.3 years, approximately. I want you to go ahead and try numbers 3 and somehow 8. I don't know what happened there. That's 8 instead of 4. Try those out. See if you can get the answer. Number 3. There are 225 wolves in a state park. There's our beginning location. 225 wolves. All of these seem to have to do with wolves right now. The population is increasing. Still growth. At the rate of 15% rate per year. These are growing a lot faster, 15%. How long will it take the population to reach 500? So again, y equals a parentheses 1 plus r to the t. I know I'm using that one because it is growth. We start at 225. 1 plus 15%. Move the decimal place. So it's 0.15 to the t. Add those together and you get 1.15 to the t. That is part of my answer. The next part. I need to see when it will reach 500. So that equals 225 times 1.15 to the t. Again, plug it in your calculator, see what you get. Make sure you get that t is approximately 5.7 years. There's the second solution. I need both because it says you want to make a prediction. It says create an exponential function here and solve here. Number 8. There are 175 deer in a park. Finally, not wolves. The population is increasing. Evidently, we're not going to have a decay on this. At the rate of 12% each year. You want to make a prediction for how long it will take to reach 300. Take a minute, figure this out. Increasing, a times 1 plus r to the t. Y equals, they start at 175. We have 12%. Move the decimal place over, so we have 0.12 to the t. Combine, you have 1.112 to the t. We want to know when it reaches 300, so 300 equals 175 times 1.12 to the t power. Use your calculator to find out how many years that is. You need both answers. You should get t is approximately 4.8 years. It should take about 4.8 years for the population to be 300 deer. There is exponential growth and exponential decay, which is also an exponential function. Anytime inside the parentheses you have a value that is greater than 1, you have exponential growth. Anytime it's a value less than 1 in the parentheses, you have exponential decay. We'll talk more in class about how to identify that.